Hello friends, in this video I am going to explain a new concept called Spec Spectrum. So in the digital communication we modulate the signal and we transmit the signal through the channel. But when a signal is transmitted over the channel, there are a lot of difficulties or the problems the signal has to face, like security issues or interference problem. So to avoid these problems, we use a technique called Spec Spectrum. Now what is this Spec Spectrum is, we will understand in this video, the basic concepts. Now, Spec Spectrum definition says, this is a process in which a signal occupies a bandwidth which is much larger than the bandwidth usually required for transmitting a modulated signal. Usually the bandwidth, see, when a message signal or is converted into modulated signal and transmitted over the channel, we actually expect the bandwidth occupied by the signal to be very less. Also, the power of the signal. The power of the signal is very large, should be large. So these two are the important parameters what we consider. The one is the bandwidth should be small, the power is large. Because power is large to avoid the interference or the noise effect. But in the Spec Spectrum, what exactly we do is we compromise on the both. That means we actually occupy all the bandwidth whatever available for that particular communication application, like maybe a mobile communication, television application or whatever. So the first point says here, just look at this point here, is the process in which signal occupies a bandwidth which is excess of the minimum bandwidth required to transmit the data signal or a message signal. So as you can see over in this figure, this is the power. The power is actually reduced much. So this diagram actually says narrow band information signal before the spreading. So it has got a large power and very narrow bandwidth is the frequency axis. The x-axis is the frequency axis. So it has occupied a very small bandwidth and a large power. This is the normal communication of a modulated signal, say ASK, FSK, PSK, whatever the type of the signal is. But by using Spec Spectrum, we compromise on both. The power, intentionally we reduce the power of transmission and just look at this frequency spectrum, the bandwidth occupied. The bandwidth occupied is very large. This is for the Spec Spectrum signal. Now what is the advantage of doing this? We will understand this in this video or maybe in the coming up videos, in the next videos. Now how to achieve this? How to achieve this, a widening of bandwidth? That is we use separate a code called PN code. A code called PN code. The PN stands for here Pseudo-Random Noise Code. It is a pseudo-random noise code which is used for spreading the message signal over the large bandwidth. And remember, the same PN code we have to use in the receiver if you want to get back the original message. So in that way, some security is actually added for transmission, which is more advantageous. So the major application of this Spec Spectrum is security. We provide a security. How we provide the security? Because without knowing the same PN code in the receiver, it is impossible to get back the original message. So we use this pseudo-random noise code to spreading as well as we call it as despreading in the receiver. So somehow the security is actually added to the signal. That is the main advantage of Spec Spectrum technique. Now, what are the different types of techniques? The types of Spec Spectrum technique. The one is called direct sequence Spec Spectrum. The second one is called frequency hopping Spec Spectrum. So we have two different methods called direct sequence Spec Spectrum. In short, it is called DSSS. The second one is called frequency hopping Spec Spectrum, which is called FHSS. Now, in both the Spec Spectrum method, we actually use this PN code. So what is this PN code is, we will understand this later. We use the PN code for spreading the purpose. In the direct sequence Spec Spectrum, we actually multiply the PN code, which is usually having a very large bandwidth. Remember, this is having a large bandwidth. My signal is having a small bandwidth, a baseband signal, let us say, a digital data, maybe, simple digital data, maybe, or modulated signal can be, whatever. So, the small bandwidth signal is multiplied with a large bandwidth signal in this method, direct sequence Spec Spectrum method, and hence the bandwidth of multiplied signal will be increased. and after that we use a PSK modulation technique and we transmit the signal. Now in the frequency hopping spectrum, it's the frequency hopping. Hopping means changing, jumping between the two different carrier frequencies. So we are not going to modulate the signal by using a single carrier frequency, but we continuously change the hopping frequency. We change the frequency of the carrier continuously. So that change of carrier frequency depending on the PN code. So without knowing, so it depends on the PN code value. So without knowing that PN code value, we don't know the hopping process. So it is impossible to get back the original signal. That's how the security is added. So we will understand this later. Detailed working of both the methods we will understand in the next videos. Now going to the application part of this Spec Spectrum. Now why it is required? I told about this, the first point, the secured communication. Example, maybe military communication or it may be a mobile communication. As I told earlier, in the mobile communication usually only the sender or the called party and the calling party should communicate between them. No third party or the unauthorized person should be able to listen to the conversation what is going between the called party and the calling party. So if I use this Spec Spectrum technique by using a PN code, security is automatically added because only the calling party and the called party know the PN code. So basically it is actually used in the CDMA technique. Like say CDMA means code division multiple access technique. So in this technique, this method is actually used. This is one of the multiple access technique what I have mentioned over here. So the second application of this Spec Spectrum is you can avoid this jamming or intentional interference of the signal. Now what is this jamming is? Mobile jamming, you know. When a signal is transmitted over a channel, what can these jammers or the unauthorized persons can do is they can also transmit another signal within the same bandwidth of my transmission. My carrier frequency, my bandwidth, within that bandwidth, if they know what is the carrier frequency used, they can also transmit their signal, a jamming signal, in the same channel. So my receiver will receive, if it is a very high strength signal, my receiver will receive that signal and my signal is actually suppressed or it is jammed. So the communication is actually blocked here between the two, sender and the receiver in this way. That process is actually called jamming. So anti-jamming is one of the important application of Spec Spectrum. As I told earlier, military communication, security is increased, jamming can be avoided in the military communication. Now one more application of this Spec Spectrum is multipath rejection. In the mobile environment, environment means it's a free space communication. In the free space communication, usually signal will not go directly from signal will not go directly from the sender and the receiver. Signal that is called direct communication. In a direct way, the signal traveling from the transmitting antenna to the receiving antenna. It is not going to happen. It will take multiple paths. The signal will take multiple paths. It may go and hit the earth surface and go to the receiver. It may go and hit the buildings, tall buildings, or maybe hills, and it will received by the receiver. So for a different direction, say this may be one of the direction, this is another direct direction, this is maybe hitting some earth, maybe earth surface and going to the receiver. So multiple direction, the signal will be received by the receiver. If that is the case, now what can happen is signal will be received at the receiver in a different time and with a different phase. When all these signals are combined together, the signal strength may change. This is actually called fading. Fading means signal strength will be attenuated because of the multiple path traveling of the signal, propagation of the signal. To reject these multiple path signals, we can use Spec Spectrum technique. As I told earlier, multiple access communication, mobile communication, CDMA, PN codes are actually used for communicating to increase the security of transmission. So these are basic applications of a Spec Spectrum. We will understand these applications again later in the another video maybe. Now as I told earlier, every time I'm using a word called pseudo-random sequence, which is used for spreading as well as de-spreading of the message signal in the transmitter and the receiver respectively. Now what is this PN code is? PN code is nothing but, it is not a special code, it's nothing but, it is a sequence of zeros and ones. We have to generate this sequence of zeros and ones by using some generators, PN code generators, pseudo-random code generators. And usually this PN code is periodic. That means it will repeat after a certain bits, certain interval of time. It's basically a periodic. Same code is actually repeated multiple times. And to generate this PN code, commonly what we use is, the method used is something called as maximum length sequence code. As I mentioned over here, maximum length sequence code. So in this maximum length sequence code, we use a circuit called as LFSR. LFSR stands for linear feedback shift register. It's basically a shift register with certain feedback, linear feedback to the input. So as you know, shift register consists of memory elements, flip-flops, where we store the bits and shift the bits, and it will generate some output. So if I provide a feedback to this, it will generate a PN code, that is pseudo-random sequence code. Now if I say this is basically n is equal to 2 power m minus 1 here, n is actually called the length of the PN sequence, or it is number of bits in the PN sequence. So as I told here, this is periodic, so it will have a certain length, and after that the same code is actually repeated. So that depends on m. What is m? M is nothing but it is the number of memory elements. So if m is large, length of the sequence is large, we get a maximum length sequence. That is the advantage of this particular method. Say if m is equal to 3, 2 power 3 minus 1 will give you the length, that is equal to 8. So that 8 is the length of the bits. We have a 8-bit number, and that same 8-bit number will repeat after a certain after 8 bits, every 8 bits. If m is equal to 4, we get a n equal to 16, and so on. Now I'll go to the example, how to generate this PN sequence. Just look at this example. Now this is x1, x2, x3, x4 are the memory elements, flip-flops. So this is basically shift register. You can say SI-SO shift register. This is the output. But there is no input because it's a linear feedback shift register. How the feedback is taken? Just look at this. It's a modulo 2 adder here. The output of these two flip-flops are connected to this, and the output of the modulo 2 adder is nothing but it is an XOR gate. The modulo 2 adder is given as a feedback to the input. So it's basically a shift register with a linear feedback. This is a linear element XOR gate, and it is given back here. Now how to generate this PN sequence? I have written already the PN sequence. This is a table over here. So we have to start with one initial condition always, assuming that in these flip-flops we have stored 1 0 0 0. This is just a random number I have taken, 1 0 0 0. Initial condition can be any 4-bit number except 0 0 0 0. Except 0 0 0 0. Why? I'll tell you later. Why we can't consider 0. Now in this case, these columns actually represents the output of these 4 flip-flops, and the 4th flip-flop will give you the output. This one, pink one. And after certain interval, the same thing will be repeated. Why it repeats, I'll explain. Now, so in this case, initial condition is 1 0 0 0. I have taken an initial condition as 1 0 0 0 over here. If this is the initial condition, 0. Now, how to generate the output? See, the output, this x2 is nothing but the next state of the x2 is nothing but it is the x1. The next state of x3 is nothing but it is x2. The next state of x4 is the x3. What about x1, the next state? It depends on the modulo 2 addition of this and this. That is, you can say here x3 XORed with x4. See, here we get x3. Okay, so we get x3 here. x3 XORed with x4. Very sorry, it's very difficult to write over here. x3 XORed with x4 is the input for this. That is the next state. So this and this x3 and x4 will decide so the function of x3 and x4, the modulo 2 operation of this and this will decide the next state of this. So this output depends previous this condition. Just see here, x2 is about the previous output of x1 when a clock pulses are applied. So I'm going to apply a clock pulse, shifting happens. This x3 is this bit. This one is nothing but this bit. It's a simple shifting of the bits over here. Just look at this simple shifting. Is it right? This is simple shifting over here. Simple shifting. What about this number? It is nothing but it is the modulo 2 addition or XOR function of this bit and this bit, x3 and x4. 0 XOR with 0 is this 0. 0 XOR with 0 is 0. 1 XOR with 0 is 1. 0 XOR with 1 is 1. 1 0 XOR with 0 is 0. 1 XOR with 0 is 1. So like that we are going to get a next state of each flip-flop. Simple shifting. So this is shifted, shifted, shifted. 1 XOR with 0 is 1. So if you go on doing this, after a 15th clock pulse, just look at the state of the flip-flops. It is 1 0 0 0, which is nothing but it is my initial condition. So once I get an initial condition, same state should be repeated again. That means same sequence will generate. Output, just check the output. Output is nothing but is the output of the last flip-flop. The last flip-flop output is this. Only the pink colored numbers we have to consider. So when I write those pink colored numbers, say 000, 100, 11, 01, 0 and 4 ones, I have written over here. That is the output sequence. How many bits are there? 15. What is the method here? See, n is equal to 2 power m minus 1. I have a 4 flip-flops. If there are 4 flip-flops, 2 power 4 minus 1, 15. 15 is the length of the sequence. So once that 15-bit number we get, again same code will be repeated, which is periodic. Fine. Now this PN sequence generator or a PN sequences have got a certain properties. What are those properties? So it has got some randomness of PN sequence is tested by using these properties. What are those properties? The properties are balance property, run length property, or run property we say, or correlation property or autocorrelation property. So basically 3 properties are there. Now what is the meaning of this? Balance property. So in the balance property, just see, same example I have taken over here. The balance property says number of ones in this always, remember it is always, number of ones in the sequence is always 1 more than number of zeros. That means you just count the number of ones here. 1, 2, 3, 4, 5, 6, 7, 8. 8 ones are there, that means 7 zeros you should have because it's a 15-bit length. So the number of ones is always 1 more than number of zeros. So that is called as balance property. So whatever the number of bits, number of memory elements you use, if I use 3 memory elements, 8-bit sequence I will get out of 8 bits 4 ones and 3 zeros. That's what we will get. So in this example, 7 zeros and 8 ones, that meets the balance condition. This is always in the PN sequence generator or maximum length sequence generator. This is first one. Now second one is run length property. See, before going into this property, what is the meaning of run? Run means it is a subsequent identical symbols. Now just look at this. Subsequent identical elements, 3 zeros followed by different bit, 2 zeros followed by 2 ones, 0 again this is followed by 0, followed by single 1, followed by single 0, consecutive ones. So consecutive same elements, same bits is actually called run. Fine. Now what is the total number of runs, or what is the number of run actually we get? It's not length, not length, it is run. I'm very sorry for this. It's a run. Number of runs what we get is always equal to n plus 1 divided by 2. What is n here? N is the length of the sequence. In this example, the length is equal to 15. 15 plus 1 by 2 is 8. So total number of runs what we have here is 8. Out of 8 runs, what are those 8 runs are? Consecutive 3 zeros I have. This is one subsequent subsequent identical element, followed by a single 1, 2. This is third one, this is fourth one, this is fifth one, this is sixth one, this is seventh one, this is eighth one. So different here. The bits are different here. So consecutive similar element we should have. So 8 is the length of this particular sequence. N plus 1 by 2 is the general formula for any maximum length sequence generator. Out of those number of runs, n plus 1 by 2, in this case 8, usually 1/2 of the runs are with a length of single bit, 1/2. 1/4 are with a length of consecutive 2 zeros maybe, 2 ones maybe, with a length of 2 you can say. 1/8 with a length of 3 and so on. If I apply to this example, here, 1/2 of the length with a length equal to 1, that's what I said. Half means 4 in this case, because total number of runs are 8. Out of that, 4 with a length of 1. Which are those? This is 1, this is 2, third and fourth. So we have a 4 with a single bit, length 1, and 1/4. 1/4 means 8 by 4, that is 2, with a length of 2 bits. This is 1, this is another one, only 2. And 1/8, that is 8 by 8, only 1, that is this one. And remaining is always equal to 1 only, the highest next number with a length of 1 only. So this property is actually called run length property. Now the third property is called autocorrelation property, or simply called as correlation property. Again, this autocorrelation property is also periodic, and it is binary value. Binary value means only 2 values it can have, only 2 values, and it is periodic, repeats. Fine. So in the polar format, the autocorrelation function is actually given by this. This is how we actually calculate the autocorrelation function in the PN sequence generator. That is RC of k, where k is called as the lag of the autocorrelation, or it is a delay, shift. It is given by 1 by n. N is the period or the length of the sequence. Summation Cn minus k. Now what is that Cn and Cn minus k? I will tell you later. Cn and Cn minus k, Cn minus 1 is polar format representation. It may be plus 1 or minus 1 depending on the bits in the PN sequence. If the PN sequence bit is 1, taken as plus 1. If it is 0, it is taken as minus 1. Cn minus k means this is the nth bit, and nth minus 1, n minus kth bit. We have to consider those bits. For different values of k, we have to calculate this autocorrelation function, and always it is 2 value. Either it is equal to 1 or it is equal to minus 1 by n. It is equal to 1 if k equal to in. I is an integer, n is a periodic length. I usually will take it as 1, and for if I tell you exactly, for k equal to 0, it is equal to 1, and for k not equal to 0, it is minus 1 by n. That is the autocorrelation values. Fine. Now I'll take one more example. I'll explain all the properties. Now just see this example. I have a three memory elements. I have a modular 2 adder. This and this are connected. And remember one more point here. It is not that only the last two output of the last two is connected to the XOR gate. We can connect this as well as this. We can connect all the 3 outputs of the flip-flops to the modular 2 adder. We can connect any one also. Anything is allowed. It depends on the designer. Fine. I said we cannot consider initial condition. In this case, initial condition is taken as 1 1 1. Now just look at this. So A is nothing but it is B XOR C, correct? B XOR C is A. What about B? B is A, C is B. That's what I have written over here. So A, B, C, this is the initial condition. B XOR C will give you the value of A. I get this value here. A, this is A, B is A, C is B. That is the next state. So that means if this is the initial condition, B XOR C, 1 XOR with 1 will be 0. Now A will be B, so A value will go to B here, and C will get a B value. So it's a simple shifting operation, that's it. Another way I have written, that's all. So once I get 1 1 1 again, after 8 clock pulse, 1 1 1, I get an initial condition. Now the C output of the C is this C is nothing but it is the PN sequence, that is 1 1 1 0 0 1 0, 1 1 0 0 1 0. How to check the properties again? Balance property. How many zeros and how many ones? Number of ones should be 4 in this case. Number of zeros is 3. See, 1, 2, 3 and 4. So 3 ones are there. So number of ones are usually 1 more than number of zeros. What is run property? The total number of runs are 4 consecutive combinations. So out of that, half will be with a length 1. That means 2. Where it is? See, one is here, other one is here. That's it. Done. 1/4 of this means only one will have a length of 2. This one, and the remaining is this. That's it. That is the run property. What about correlation property? Now just look at this correlation property. See, I said Cn will be Cn to Cn will be C1 to C7. I have taken. These are the amplitude levels: +1, +1, +1, -1, -1, +1, and this has a -1 also, which is missing. I'm very sorry for that. It's a -1. So my number is actually 1 1 1 0 0 1 0. So +1 +1 +1. Polar format representation. +1 +1 +1, -1 -1 +1 and -1. So this is the amplitude level we have assigned. How to calculate the autocorrelation values? 1 by n summation this to this. For different values of k we have to calculate. So for k equal to 0 we have this value. For RC of k 1 by 7 summation 7 is the length of the PN code, summation Cn minus 0. Cn minus Cn into Cn is Cn square. That's it. So what is Cn? These are the values. I substitute here Cn1 square, Cn2 square, something like that. I put these numbers here. What is the answer I got? The answer is 1. You can verify that. This is for k equal to 0. So k equal to 0, RC of 0 is always equal to 1. That's what I told earlier, right? For k equal to 1, For k equal to 1, it is Cn and Cn minus 1. So C0, in this case C1, if I substitute the values of n, if I take the summations, C1 n equal to 1, C0 C1 0 plus C2 C1 C3 C2, go on doing this, C7 C6. Why is C0 here? Because it is periodic. There is no C0 here, right? I don't have any C0, C1 to C7 only, but this is periodic. Previous bit to this is nothing but it is C7. So C0 is C7. What is C7? C7 is minus 1, correct? Because it is periodic. So C1 C0, so C7 it is only. C7 is minus 1 because my last bit is 0. So just multiply this, add this, cancels, we get a minus 1 by 7. So we get a minus 1 over here and minus 1 by 7. For k equal to 2 also we can verify it is minus 1 by 7. So we can generalize it. RC of k is equal to 1 for k equal to 0 and it is minus 1 by 7 for k not equal to 0. I can calculate this for k 1 to 6 depending on the length. Length is 7, 1 to 6, 0 to 6. If I plot this, k equal to 0 it is 1 and for k not equal to 0 it is minus 1 by 7. Minus 1 by 7. If I plot it, just look at this. This is my polar representation of my bits. 1110010 is my number. I have taken 2 times. I can consider 3 times. I can consider 4 times because it is periodic. 1110010. So for this case, for 0, for n equal to 0 means at this instant of time, n equal to 0, it is 1. It is 1. For n equal to 0, for a second repeated sequence, it is 1. For n not equal to 0, for all the values, it is minus 1 by 7. For again n equal to 0, it is 1. For a previous case, n equal to 0, it is 1 and it is decreases here. For n not equal to 0, it is minus 1 by 7. So it is, this is the autocorrelation function what I will get, minus 1 by n or minus 1 by 7. And it is periodic because it is repeating. For every sequence, it is, it is repeating. Right? So this is the basic concepts of Spec Spectrum. So in this video, I have explained what is Spec Spectrum is, spreading over the large bandwidth and transmitting the signal intentionally with a low power so that other unauthorized persons not able to detect your signal. That is the advantage of this. The low power signal looks like a noise. It is a noise for the other unauthorized persons and only those persons having the PN sequence can able to detect your message. This is the advantage of this particular method. Fine. And I have also explained what is the meaning of PN sequences, zeros and ones, how to generate PN sequence and what are the properties of PN sequence in this video. Thank you for watching.